A warm welcome to everybody. We would be continuing with our sessions for the TDL procedure capabilities, well known as user-defined functions. So basically, what are functions? Functions are nothing but procedures that helps you to execute a set of statements together in a sequence to perform a specific task. These functions may or may not take inputs from the user, but depending upon the utilization of the function, there may be or may not be an return value or basically an output to it. For validations or there is just a checklist, then there might be no return value to the calling environment of the function. Now functions in TDL. Since TDL is a non-procedural language, we have broadly classified it into two categories. We've already said about TDL being non-procedural, right? So at the function level, TDL is procedural because here is where we'll have to mention these statements to execute actions, and based on how we specify the sequences, we would be having the output. So the two categories of the functions that we have are the platform functions or the user-defined functions. We will have some set of platform functions, some frequently used platform functions to read through, but that would be at the end of the session. Right now our focus would be on the user-defined functions. Why would us, when we already provide us a huge set of built-in platform functions, why would anybody require to build a function? This could be to perform any specific task in a specific order. This could be where the application developer has no control over the sequence of these functions, and they can be used as and when required to achieve a specific task. For example, multiple creation of vouchers. Currently, we have provided a duplication of voucher where you manually have to, user has to press Alt 2 to duplicate and press enter to replicate the voucher. Well, this can be done at the click of a button where a specific task is to duplicate the voucher, and user do not have to even not do anything else apart from just clicking the button. The entire control will be taken up by the developer. The TDL functions are the action statements that are defined by an application developer. The developer has a complete control over the sequence in the serial the actions will get executed. This developer is talking about the TDL developer. The definition type function is used to create functions. What is the benefit to a TDL programmer? Control over the evaluation or the execution of the statements, repeated execution of the set of statements, to accept parameters from the calling segment, to work on data elements like getting an object from a calling context, defining the function execution, looping objects over a collection, and based on, say, I want to create 10 vouchers. So there could be a loop which creates 10 objects of voucher. So the function will help us to do a repeated steps, control over the execution. You can provide an if-else condition to throw an output. You can provide a while loop. You can provide end-if loop. So depending upon the controllings and the executions required, the entire behavior can be controlled. Calling a function. Basically, a function is created with two purposes. One, to be used as action performing a particular set of tasks without returning a value. In this case, we can use the action keyword call. And to be used as function performing complex computation and returning a value to the calling program. In this case, we can use the symbol $$ to call a function as we do for a platform function. So does this mean if I write call as an action keyword, we cannot return a value? You can return a value. This is a generic utility, the purpose that the moment you make use of the call keyword, the expectation of that you return a value reduces. Similar with $$, yes, you may return a value, may not return a value depending upon the utility. The action call, it's a keyword, so it's a global action, an action created by programmer using function definition has to be called by using the keyword call colon the function name colon the parameter list is optional depending whether the function requires an input or not from the user. So this is an example that we are calling a function. Simple, you can say call colon the function name. $$ prefix, $$ symbol is prefixed to a function name when the function is used inside a value expression or as a value for a set as attribute of the field. $$ function name. Again, the parameter list is optional here. Only if the function accepts parameters, you will have to provide a parameter. So this is an example. We have provided an example. Let's set as there could be a function which might be utilized for some other purposes. You can call it the same way. Function building blocks. There are two blocks in a function. A definition block and a procedure block. Definition block is the specifications that are done in the block. What variables you need, what parameters you will require, how many parameters, and what will be the return value, whether it will return a value, what will be the return type of the value. So those are specifications will be provided in the definition block, whereas the procedural block will have the statements of execution. For in the sequence, the statements of actions that will be provided in the procedural block. This is how, and it has to be mentioned in the sequence because that is how it will perform the action. So this is one basic structure. Not necessary that you might have to use a definition block and you might have to use all the definition, all the details that are mentioned here in the definition block. Depending upon the requirement of your function, you may require a definition block or you may not require a definition block. So the definition block consists of the parameter declaration, variable declaration, list variable declaration, static variable declaration, object specification, local formula specification, and return value specification. The parameter declaration is used to declare the list of parameters that has to be accepted from the user. These values are passed to the functions and referred as variables within the function. As we know, variable are the only free elements within TDL that can pass value from one element to another element. So any values that you want from the user to be passed to the function, all this will happen through variables. So parameters will take the variable names. which means that these variables will be carrying values that will be provided from the user. The parameter declaration would be parameter colon variable name colon data type and colon parameter value. The parameter value will be optional. Variable name will be the variable that will hold the value the system receives from the user. Data type is the type of value that this variable will hold, and parameter value is an optional value. If the values for these parameters are passed from the user, then this particular variable will carry that value. However, if the user does not provide any input, that is in the absence of the input from the user, this would be the default value of the parameter variable. So, if the user provides the input and the parameter value exists, the user input will be having the higher precedence. However, if it does not, if the user leaves the field blank, then it will take the parameter value as default value. So this is one example. Parameter colon the parameter name colon the data type. This is another sample. Do not get into too detail. We will see how to create functions once we reach a level of understanding at least few actions what we can use, right? So again, it is taking two parameters as input, and you can see here we have an optional parameter character. So if the user gives the input, that would be considered. If the user does not give an input, slash will be the default value. Variable declarations. Parameter variables are those variables that will bring values from the user. However, variables can be used inside the function for an intermediate use. Probably when you do some addition or subtraction, you need to hold the final value into another variable. You might require that variable, or could be for some more other reasons. Variables should be declared in the definition block before you bring them to use. The scope of these variables will be within the function and to any report or function called from the function. So till the function exists, the variable exists. Once the function calling is closed, the variable is a self-destructive. So the variable will exist only till the caller parent report or the function is available in the scope of that function. Syntax is similar. Variable colon the variable name colon the data type colon the value. The data type is optional parameter to the specified data type of simple variable. It is in case it is a compound variable, the data type cannot be specified here. There is a detailed chapter on what's a compound variable and what's a simple variable. So do refer to the variable framework framework session, and you would understand this in more detail. Data type is mandatory for simple variable. In case of compound variable, data type cannot be specified here, as it consists of members. If the data type is not mentioned, the primary variable definition is mandatory. So this is called an inline variable. If you provide a data type here, then it is absolutely okay. You do not have to define it separately. In case you do not specify the data type here, then the definition of the variable is mandatory. So this is how we can have a function colon the factorial of input is my parameter, the value that we are going to take from the user, and we will have another variable called counter. This is what we are going to take from our for our intermediate calculation purposes. We'll have this variable. List variable. The attribute list variable is used to specify a list of either a simple or a compound variable. So how does the function judge whether it's a simple variable or a compound variable? With the help of the third parameter that you specify, whether it has a data type or it does not have a data type. If it has a data type, it is a simple list variable. If it does not have a data type, then it's a compound list variable. Please refer to the variable framework session and you will be learning more detail about the variable, simple and compound variable. So this is how we specify list variable colon variable name colon data type optional colon value. It is a comma separated list of simple or compound variables. And then optional parameter to specify data type of a simple variable. In case of compound variable, data types cannot be mentioned here. Since data type is not mentioned, you have to provide a data type variable definition, and you will have to provide an entire structure to the variable framework, to this entire variable. You will have to provide an entire structure to the member variables. And optionally, in case it's a simple list variable, you can optionally provide an initial or a default value where the customer or the user does not provide an input. If the definition is not specified, then this kind of variables are called inline declaration of the variable. So this is another example. List variable colon the variable name colon the data type. This indicates it's simple list variable. Now what's a static variable? All the variables that we discussed up till now, all these variables will be served instruction once the function completes its work. So once you are out of the function, the variable does not exist. Now, so the next time the same function is called, the variable values are reset. When it comes to static variables, the value of the static variable will persist between the successive calls to a function. Initial values are set only during the first call of the TDL. Later it retains the values for the further calls. So for an example, initially when a variable is called, you provide a default value. Now once the function completes its job and it is out, the value of that variable is reset to 0. However, if it is a static variable, the last value of the variable is retained. So the next time you call the function again, the last value of that static variable is called. Something similar to what we call a system variable. something very similar to what we call as system variable. This is an example: static variable colon sample static var colon number. So more or less, if you have noticed, the declaration, the way you write the variables are same, only the behavior of each variable changes based on what kind of with what parameter you call it, whether you call it as a parameter, you call it as a you call it as a variable, you call it as a list variable, you call it as a static variable. Depending upon that, the values will the variable will take the input. Now talking about the object specification. TDL is very much related to the data that we have. The object context is what we always talk about, the data context. So whenever the function always connects itself to the data object from wherever it is called. Hence, we have something called as object specification, where the TDL procedure will inherit the object context from the caller. So if I am into a report which has an object which is of a type voucher, when I call a function from there, the object context of that function will be voucher. That's the caller. The caller is the object report voucher. So that would be the object context of my function. In case the object context needs to be overwritten, then that can be done by explicitly specifying the attribute object at the function definition at the declaration block. The moment you specify the object context, the entire function changes its object context from the caller to the specified object. So this is how you can specify object colon the object type and the identifier if required, depending, again this depends upon the requirement of the function. The identifier depends upon the depends whether there is an object to be created or to be recorded. So the object context will change. Now talking about local formula specification. The attribute local formula is used to specify a local formula within the function block. So as we have learnt about local formulae in our basics of TDL, even function allows you to provide local formulas, a formula that will be used only within the function. So the attribute is local formula colon the formula name and the evaluation value. And finally we have the return value specification. A function can return a value to the caller and data type of the return value has to be specified. Function may return a value, may not return a value depending upon the requirement. If the function has to return a value, then you will have to specify the attribute return with the data type of the returned value. Whether it will return a number, whether it will return a string, whether it will return an amount, whether it would return a logical value, what kind of value would it return is what we will specify. So here is an example. Factorial of the parameter is input number, return is number, and we have a variable called counter, which is also of type number. This is just a high coincidence that our parameter is of type number, our variable is of type number, and the return is of type number. It is not necessary that all of them have to be of type number. Depending upon the requirement of your work, the input data types, the output data type, and the intermediate data types of the variables can be different. Now starting with the procedural blocks. It is just a set of statements, and each statement is identified by a label. A label can be any alphanumeric, but in generally programmers number it 0, 1, 2, 3, 4, 5 depending upon the requirement. Function execution object context. An expression in TDL is always evaluated in the context of the interface, the requester, and the data objected within the interface. This is referred to as the current object context. Well, before moving on to the object context, let us look at an example, a very simple example that we have in a user-defined function, where we are explaining about a mathematical thing called factorial. So let me just show you an example to that. We have samples available in help, TDL samples, user-defined functions. So we have few basic functions created. So let us just start with something very basic called simple interest. Let me show you in Tally the output. User-defined functions and simple interest. What's the formula for simple interest? Principal into rate into tenure. That's a simple interest. So we'll take something very basic. Principal amount is 10,000. Say rate is 3% and its tenure is for 5 years. So according to the calculation, it should be 10,000 into 3 into 5. So it is giving me 1,500, right? So the calculation goes as 10,000 into 3 into 5 divided by 100. That's the actual calculation. So we require 1, 2, 3. We require 3 parameters, 1 return, and we require a simple variable to take this calculation. So this is how we have done. Let me show you the code. It's a very simple function. The function is called on the acceptance of the third field. Here. $$ function. We have 3 fields for input: interest principal, interest rate, and interest number of years. These are the 3 parameters, and we are referring to the field names for the values, and this is the function. Parameter P, that's the variable name. So you see the sequence that we have maintained: P, R, T. Anyways, it's a multiplication, but yet sequencing will go. This would be the first parameter, this would be the second parameter, this would be the third parameter. It will make a difference when these 3 are of different data types. So P, R, T, it will return amount, and the variable is interest that we are using to do the calculation. What is the action to change a variable value? Set attribute. So we have an action called set at button level. We have an action called set at report level. Similarly, we have a set action at our function also. So set the variable name and the variable values. So the variables that we have is PRT. So we have to do a multiplication to all three of them. So P into R into T divided by 100. So that gets calculated here. So as per our calculation, as per what we had pushed in, it would be 10,000 multiplied by 3 multiplied by 5, the whole divided by 100, which gave me 1500. This 1500 gets set into my interest, and I say return the interest value, which is of type amount, and there it is, the output. You see, this is simple interest. Similarly, we have for compound interest, we have for exponential. Let me just show you the factorial over here. Basically, when you talk about factorial is the concept of multiplying all the numbers lower to the specified number. So if we specify 5 here, it means that we are looking out for 5 factorial, which means 5 into 4 into 3 into 2 into 1. This is what 5 factorial means. 5 into 4 into 3 into 1. So how much would that be? 120. So we should get 120. We getting that? Right. Now just look at this concept. We have one value for input, and we have a return type. We have a return. So let me show you this function. One is for input, one is for the return, one is for holding the calculation, and one is for countering the counter to pull down. That it should not go lower than 1, because again when I go to lower than 1, then it goes to negative, and then that becomes an infinite loop, and also becomes, the value becomes negative, because it will be 1 minus 1 is 0, 0 minus 1 is minus 1, minus 1 minus 2, minus 1 plus minus 1 is minus 2. So that will keep on going to the end. So this is how we have done, and we have made use of something called as a looping construct to do the work. So we'll see this looping construct in a short while. Right. So we're talking about, coming back to the discussion about the object context. So as I had mentioned earlier, the function will be connected to the data object from where it is called. Since TDL function will be performing some manipulations on the data also, it will require another object context also. The object which is being populated or altered is referred as target object. So we will have a source object from where we will pull the data, or from where we will call the data, and we will have a target object from where we will push the data. So we will have two kinds of context here in function. One would be the source object context, and one would be the target object context. The target object context refers to the object context which can be set inside the function. The object context of the caller and the target object can be different. So it's an obvious thing, can be same also, but depending upon the requirement, it can be different also. It is now possible to obtain the values from the caller object context and alter the values in the target object. So from the current object you can call the values and you can push the values to the target object. They can be same, they can be different depending upon the requirement. The function $TDL evaluates the given expression in the context of the targeted object. So within the function we will have two contexts. One is the source and one is the target. So if you simply say $name, it will fetch the value from the source object, and if you write $TDL colon $name, it will fetch the $name from our targeted object context. So using the targeted object values can be using the function $TDL values can be called from the targeted object without making the target object as our current object, because our current object still we might want to refer to our current object, and the moment you write object colon ledger at the function level, the object context changes from voucher to ledger, which is actually a big problem, which might not require that. So just to temporarily change the context for a particular value, you can make use of a function $TDL This is an example. Object colon ledger colon party 1. So my source object is party 1. New object ledger, so that's my party 2 becomes my targeted object. Set value colon opening balance. This opening balance refers to party 2 opening balance colon dollar opening balance. This refers to party 1 opening balance plus $TDL colon dollar opening balance, that refers to party 2 opening balance. So at the end, the party 2 will have the opening balance would be the combined value of its existing opening balance plus the party 1 opening balance. Parameter evaluation context. The parameter values which are passed to these functions are always evaluated in the context of the caller. The target object context or the context switch within the function will not affect the initial values of the parameters. As we always keep talking about, variable are the free elements. It does not matter to the parameters from where you are calling the value and where you are pushing the value. The values of the parameters will not get affected whether it become whatever your current object or your targeted object is. It does not matter to the parameter because it's a variable. Return value evaluation. A function can return a value by specifying the data type of the value in the returns. No specification assumed, when you don't specify returns at your function, it is assumed to be a void function, a function which will not return any value. Each statement or actions used in a function can return a value. So even if there is one statement, you can say return value. Return value of the last action executed can be extracted using an internal function $last result. So return value of the last action, what was the last action that had been performed, can be called or extracted with the help of the function $last result. Any error message generated from the system can be obtained by function $last error. The final value which is to be returned from the TDL functions has to be explicitly given using the return action. So there are certain valid statements inside the function. These statements in the procedural blocks are classified as programming constructs and actions. Programming constructs are conditional, looping and control statements. Actions is a huge list of actions. We have a lot of system actions, object and context manipulation actions, user interfaces, debuggings and file IO actions. It's a huge list, so we'll go through one by one. Coming to the conditional constructs, looping constructs and control constructs. Conditional constructs are gives you the capability of making a decision. The flow of the execution can be controlled by providing a condition, and the condition is always given in the format of if and if else and if, or do if. So there will be the series of statements between if and if. So only if the criteria is true, then the set of statements will be executed. Initially, expression is evaluated and based on the logical value of the expression. It transfers the execution flow to a particular statement. Function factorial of if criteria set the parameter name, the variable name colon the value. If colon condition set colon variable name colon the value that you want to evaluate at end if. Every beginning loop, the conditional statement should have an ending statement. So if and if, so the way the moment you write if and if is mandate. Now let us look into the next option. If else and if. How is this statement different from the previous one? In the previous one, if the conditions are true, we have a set of statements to follow. But what if the conditions are not true? We might want to execute certain set of statements. So this is where if else and if comes into picture. If the condition is true, then these statements will get executed. If the condition is false, these set of statements will be executed. This is the if-else condition. We can have a nested if-else condition or an end-if condition. So here we are saying if A is greater than B, then do these set of statements. Else, that means if A is not greater than B, that is B is greater than A, then you have to do these set of statements. So if A is greater than B, then check if A is also greater than C, then return A, else return C. But if A is not greater than B, then directly validate If B is greater than C, then return B. If not, then return C. End if, end if. This is how you can validate, find greatest numbers amongst these three. And we have a do if conditional statement where you do not have many statements to provide. Say you have only one liner if condition that can be provided with the do if. So do if is equal to if and if with one action statement. You can have multiple, you can have one. So do if is used when only one statement is to be executed if the condition is true. So you can write it with an if and if also, or you can write it with the do if criteria also. So label do if the condition is true, then display start summary. Condition colon the action. So it's label do if condition colon the action statement. Then we have looping constructs, while, ENDWHILE, for range, end for token, end for, walk collection, end walk, for collection, end for in, end for. So you see every construct that we have has a beginning and an ending. It is you do not provide an ending construct, it is an error. Your functions would not execute. While and ENDWHILE loop. This is an entry controlled loop. The first condition expression is evaluated, and if it's true, then only the set of statements are executed, and the process is continuously done till the steps of statements mentioned in this loop will continue to get executed till the specified condition is false. So the moment the condition is false, the statements that we had that were being executed will terminate. So that is while loop, and this is what we have used for our factorial code. If you can see here, while we have given the counter to set to 1, factorial 1, obviously because anything multiplied to 1 will return you 1. While my counter is less than my input number, set my factorial value to factorial multiplied by the counter if the count, and continuously increment my counter. So here we'll have a small assumption. My counter, so this is what my counter is, 1, and the input number we had was 5. So is it equal to or less than 1? Yes, it is less. So what will happen? It will go into the loop. Factorial value will be factorial, that is 1, multiplied by the counter 1, which returns an obvious value 1, and the loop is ended, and the loop is here. Then my counter value is incremented by 1. So we'll come to this action, do not worry about this. So increment counter is add 1 to the existing value of counter. So by default the current value is 1. So my counter now becomes 2 and my loop is ending here. So again it goes back to the beginning statement where counter is equal to or less than the input number. So what is the counter value now? 2. Is 2 less than 5? Yes. Then continue this multiplication. So now my counter has become 2 and my factorial value was 1. Now it becomes 2. Here now the counter becomes 3. Again it goes back to the loop. Now my counter value is 3. Is it equal to or less than 5? Yes. It is still equal to or less than 5. Now my factorial value is 2. My counter value is 3. So 3 2s is 6. Now my counter value is 4. Now we place here again 4. Is 4 less than or equal to 5? Yes, it is. Now my counter is 4. The factorial value is 6. So 6 4s are 24. Now my counter value is 5. 5. Is this equal to at less than 5? Yes, it is. So now my counter value will become 5. My factorial value is 24. 24 into 5 is 120. My counter increments to 6. Again it goes here for a check. Is 6 less than or equal to 5? No. So this is where it terminates and my current value of factorial is now 120. It is now going to terminate here and my current factorial value is now 120 and at the end simply we say return the factorial value. So this is how the while loops works. This is an example of the factorial that we have done. Then for range allows the loop allows a repetition of a loop for a given range of numbers or dates. So in the previous while loop we had given a condition that it should continue till the value is satisfied. Here you can give a range of your dates or numbers till when this particular statement should continue to increment. So for range, iterator variable, data type, the kind of data type the variable will be, the starting range, the end range. If you want to increment by, if you don't provide by default, it will increment by 1, and if it's a date increment, then you can provide a date range increment keyword. So this is how it is. Iterator variable is the name of the variable used for iteration. This variable is created implicitly just for just at that particular time. Then date type can be number or date. Starting expression is an expression which evaluates to number or date, and it refers to the starting range. End range expression is the expression which evaluates the numbers or date. It refers to the end of the values, that this should continue to happen till it reaches here. So start from here but end here. So that's the range criteria. and then the increment, this is optional, so if you do not provide an increment, by default it will be 1. And if it is dates, you can provide some keyword for the date that increase values by days or by week, by month or a year. So we have an example here where you want to get all the even numbers from 2 to 10. So we've given for range, it's a multiplication of 2 basically. So for range, variable name, the data type, that this would be of type, 2 is the starting number, 10 is the ending number, incremented by 2. So 2, then 2 plus 2, 4, 4 plus 2, 8, 8 plus 2, sorry, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, and 8 plus 2, 10. So that's how this will give you an output. So let me just show you an example of this. All the codes that are shown in this session are available in your sample TDLs. So here we are talking about here. It's there in the what's new 1.6 enhancements in user defined functions, for range and loop index. So we'll just focus on for range. Loop index function we'll see when we are coming to that. So here, for range you'll be looking out for the machine date. So the beginning is the current date and the machine date increment by 1 day. So this will say how many days we are behind schedule. Say your current date in Tally is 4th Feb, but machine date shows that today is 18th Feb. So the difference between these days will be your date. So the difference is what it is going to provide you the output. Now, why would we require a for token? It is used to loop on a string expression and return one value at a time. So the set of values will be separated from each other with the help of the delimited characters provided. Say for example, we have a series of values in a string, and when you break, you get the details. What is the batch number? What is the manufacturing date and expiry date? But the number of characters are not fixed, so you don't know. But one thing that you are aware of is that it is separated by a hyphen. So you can make use of a for token loop to separate the string expression from the delimiter. So the iterator variable, again this can have the iterator variable implicitly, it will be created implicitly. It has to be a string expression and can be and the delimited character can be any character for separating the string. But again, this value is optional. So if you do not provide a delimiter character, by default it is separated by colon. This is, and last we have something called as bracket flag. It is used to consider the brackets while deciding the separator character, whether the bracket should be a part of my expression or not. So this is how we have provided. So the moment you write like this, it separates your values and breaks it up into multiple values. Let us just have a look at our sample for token. So we'll just run this sample here. It's in release 1.52 for token. Here we have the values. So for token shopper, this is the values that are separated. Then brackets available, quotes available, so there are multiple options to this. So let us just see the code. For token, the variable name, the string expression, you have provided a comma delimiter within the quotes, and you have said false. That means brackets aren't to be included, aren't to be considered. So we get tally shopper, tally developer. Then we look into for token without brackets again. Tally shopper, tally developer. So that then it again returns same output. Then we for token with inverted quotes within the string character. So you write for token tally colon tally shopper. So if you have given it within quotes, then this colon will be ignored. So this is what we have here. It is within quotes. You can make use of a formula to give your output also, which is having a bracket. So you can maintain the bracket if you want. So again, these dependencies are there. So you can provide multiple formulas to give your output. So if bracket has to be considered, say true. If bracket does not have to be considered, say false. Then we have walk collection. When a loop is required to be repeated based on number of objects in the collection, this looping construct can be used. So we can have a collection created of an internal object type, and you can loop on that collection, and some set of actions can be executed. Body of the loop is executed for each object in the collection, making it the current object. So that will keep on looping till we have all the objects exhausted within the collection. This can help you to create more ledgers or more vouchers, or a number of things can be made possible. For collection and for the looping construct for collection provides a context-free walk since the object is not set as the current object. The difference between for collection and end walks, the first difference is when the moment you write walk collection and you provide a collection name here, this collection becomes your current object context. So that is the object switching context here. However, when you use a for collection and you provide a collection name here, it does not make the collection as your does not change the object context of your collection of your function, yet it fetches value from the collection. It loops on the collection for specific values and returns the values in the iterator variable. So your object context does not change, yet it brings the value from your current collection. So the iterator var is the name of the variable for the user for the iteration. collection expression can be any expression. So it can be a variable name, it can be a formula, anything, but should evaluate to a collection name. Can be an expression and the value of this is returned in the iterator variable. If the value expression is not specified, the name of the object is returned. Reversal flag again is an optional thing. What will happen is, by default, the collection rollout will start from 1, that is from the top. However, if you want to go from a reverse order, that's from the bottom, you can say from the reverse order, yes. So it will start from the reverse order. So when you say yes, it will start from the bottom. If you don't provide anything, it will start from the top. Similarly, we also have the same optional reversing flag for our walk collection. For in and end for in loop is supported to iterate the values in the list variable. For token was for to iterate the values of a given expression with the help of a delimiter. For collection is to loop on a set of collection. For in is loop is used to iterate the values in the list variable. The number of iteration depends on the number of values in the list variable. The construct will walk only the elements in the list which are having a key. So it is very important to understand the list variable, the variable framework for this particular looping construct. For in iterator variable and the list variable name. You can provide the statements within it and you can go ahead. List variable is the name of the list variable. For each is the alias for the foreign looping construct. So either you can use for each or you can use for in. Either is okay. Both are the same. Then we have a function called $loop index. What we spoke about all the looping constructs. We had while and while. We have walk and walk. Then we had for range, for token, for in, for collection, walk collection. All these are loop. Now to count how many loops we have, we can have a function that is called $loop index, which is similar to like $line. We do have a function called $line. This is similar to that. So the function $loop index returns the count of how many times the loop is executed. So $loop index will return say 1, 2, 3, 4. As we can have, it can be a nested looping condition. So we do also have something called as outer loop expression. This can be an expression which evaluates to a number. It is optional and the outer loop index is the nested loop hierarchy from the innermost loop to the outermost loop. So say we have an object context of voucher, inventory entries and batch allocations, and you say $loop index. So $loop index will return you the looping of your batch allocations. Now say you want the looping index of your ledger entries. So you say loop index : 1. So which will go to the parent loop and return the number of times the ledger entries have got looped. And then if you give 2, it will return the looping construct of your voucher. So that's how it goes on. Then we have the control construct. Although the loop performs a set of operations repeatedly until the condition expression is true or the collection is exhausted, at times we are required to exit the loop or skip a part of the loop based on certain conditions. For example, when we talk about a factorial, it is a multiplication of the number provided to the number till we reach 1. So it is 5 into 4 into 3 into 2 into 1. Now we'll just take the same example. We'll go to the same looping construct. Now say I give looping construct of 10. That is somewhere around 36,28,800. Now say I give of 11. That goes to some 99 lakhs 16,800. Now multiply this by 12. So it goes into some 4,790 lakhs 1,600. Then we multiply this by 13. Multiply it by 14. You multiply it by 15. You multiply it by 16. So you see the number it is getting into. It's such a huge number which even a simple calculator will start throwing error. So now when we multiply by 17, although the number of the value is here, what we have done is we have given a control at field level, but instead of that you could have allowed the control to go till the 16th time and provided an if-else condition that if the value is 17 or greater than 17, give the output result of 16 and mention that that the calculator can provide a factorial up to 16 only. That can be done, and you can give a break statement there, that it should break and should not continue further. So when a break statement is encountered inside the loop is immediately exited. The control is transferred to the statement just after the loop is over. In scenarios, instead of terminating the loop needs to be continued with next iteration after skipping some statements in between them. That is where continue is used. Is the statement which is used to return the flow of control to the program. So if with or without a value. So if you write return with a value, it returns back with a value. If you do not provide return the value, it will just simply return the control back to the application after the set of actions are performed. And we would be continuing this further in our video 2.